This funny looking thing is called an ice cube relay, and this is the relay's cousin, the contactor. They basically do the same thing. The relay is a switch that flips other switches. Now, why would you want to do such a thing? There are all sorts of clever things you can do with something like this. The first time I used a relay was when I wanted to automate my dust collection system. I got tired of having to turn on my table saw or my bandsaw or whatever, and then I'd have to walk over, flip on the dust collection system. I'd have to open the right blast gate, and then I could collect dust. What if you could automate that process? You flip one switch and all the other switches also flip, and the right switches flip. That's what this can do. And this can do so much more than that, but we're just scratching the surface. So anyway, once I learned how to automate my dust collection system, I felt like I had gained a superpower. And that's what I want to give you today. I want to give you the superpower of automation, and not just the relay. I'm going to show you a whole bunch of components that you can use, which will take your projects to the next level. Once you break through this door of automation, your projects will never be basic again. Let's get started. To get into automation, one of the first things we need to be able to do is supply DC power to our projects, because very often these small components like relays will need DC. Not all of them, but we'll get into that a little bit later. To get DC power, you're going to need a DC power supply. We'll consider this to be the first and most basic tool in our automation toolbox. And that's what I have displayed on my workbench here. All this does is take the mains power from the wall, your regular outlet, and give you the appropriate DC power that you need. Not all of these are the same. They have different amounts of power that they can provide, as well as different voltages that they provide. For example, if you want to use a Raspberry Pi in your project, which requires 5 volts, then of course you'll need a 5-volt DC power supply. And you would likely want your relays and your other components to be 5 volts as well. And you'll have to kind of shop around to try to match things up. But you can also get power supplies that give you more than one voltage. So let's take this one, for example. This can take an input from 120 to 240 volts AC. And the label will tell you what you can get there. So if we plug in the V1, we get 5 volts. And if we plug in the V2, we get 12 volts. It could be used to power something like a Raspberry Pi, as well as this 12-volt relay. And again, I'm going to tell you how to use the relay a little bit later. Generally, you can break them up into 2 categories of power supplies. There's the more industrial ones, which I'm going to push this way, and then what we'll just call the hobby DIY level ones, which usually look more like this. The industrial ones usually have this funny looking mount on the back. This little bracket is for something called DIN rail, and this is DIN rail. I love using this stuff. It's really durable. It lasts a long time. Again, because it's for industrial applications. The downside to using DIN rail components is they tend to be more expensive. So this one will give you 5 volts DC, but most of the time, if it's an industrial component, it'll be 24 volts. Although, if you look a little harder, you can get them in other voltages. The hobby level ones usually look like this, and instead of DIN rail mounts, they just have screw holes that you can just screw it down to a piece of wood or a panel or whatever you're using in your project. And I have a bunch of these laying on my workbench because I want to show you that this is literally the same thing as this. It's just very small. So in some cases, you could use something like this for your project. The catch is you got to make sure that it can handle whatever your current needs are for your project, as well as the right voltage. If we're talking about a relay, somewhere on the spec sheet that comes with this, it'll tell you how much current this will draw when it's activated. So if it's 12 volts DC and it needs, I'm just making up some numbers here, if it needs 1 amp to run, it's probably something a little less than that. Then you need to make sure that your DC power supply, which you're using to power it, can handle that much current. And whatever else is plugged in, because you may have more than one thing plugged into it, it needs to be able to handle the current of all the things plugged into it added together. This particular one can handle 3.5 amps. That's going to be the upper limit of what you want to use this power supply for. This power supply, if we zoom in, you can see that it's 24 volts and it can handle up to 14.6 amps. So pretty decent sized power supply. The plus and minus voltages here is for my power out. This little symbol is for ground. And then you've got your neutral and your line voltage. One other thing I want to say about power supplies is that the ones that have a really wide voltage range, which is actually most of them, will sometimes have a switch to indicate what the input voltage is. So these wall warts, for example, don't need that. You can plug this into 120 volts. You can plug it into 240 volts and it'll just do what it's supposed to do. But this one actually has a switch on the side where it says 115. And if you flip the switch, you can see it says 230. Now, for the purposes of this video, 200, 220, 230, 240, those are all basically the same thing. It says 115 on this side. It could be all the way down to 100 or up to 120 and you'll be just fine. In fact, the supply voltage at my house is 125. And that'll work just fine here. Usually it's obvious on the power supply which side is negative and which side is positive. It'll be labeled. But with these little wall adapters, that's not always the case. This is one that actually has it labeled. You can see here it says white plus and black is negative. But in my experience, it's the other way around. The one with the white stripe is usually the negative one. So I tested it to make sure. And sure enough, we got 24 volts positive. If it's the other way around, then you'll see a negative voltage on your multimeter. And you probably already noticed, but just to be really thorough, you can see it's showing a negative voltage, which means the leads are reversed. The bottom line is if it's not labeled on the back, and most of the time it's not, you're going to need to check and see which one's positive. Generally speaking, the more power you need, the larger the power supply. Hopefully that's obvious, but here's a really good example. These are all 24 volts. This one can supply 1.3 amps, this one 3.75 amps, and this one 10 amps. Another thing to pay attention to is that it's got these vents on the side to allow these to cool because they will dissipate some heat. So if you put this inside of an electrical cabinet, you need to make sure you have adequate ventilation so that these can stay cool. Okay, I think you got plenty to work with regarding the power supply. Let's put some more tools in that automation toolbox. Another important tool to remember that you have is access to digital manufacturing. This is where my sponsor Jigga comes in. You don't have to own and operate every kind of CNC machine just to get the occasional metal part manufactured. I spent years saving up to get this thing and still had to learn how to use it. That's because I make a lot of parts. So if you don't have the time or the skill or the manufacturing capabilities or even just don't feel like doing it, you can just send your 3D models or drawings to Jigga and they'll connect you up with industry level manufacturing all over the US and around the world. You can call multiple manufacturers to make sure you get the timing that you want as well as the price that you want. And all of your communications is directly with the manufacturer. You will be talking to the people who are working on your part. So if you need to get parts made, I suggest you check out the link I have down here in the description. And they'll take care of you. Thank you, Jigga, for sponsoring this video. And let's get back to some more electrical engineering. The relay and/or contactor is probably the most important electrical tool you need to have in your automation toolbox. I mentioned this at the beginning of the video, but a relay and a contactor is pretty much the same thing. You could think of the contactor as like the big brother of the relay. If you've got a very high powered circuit, large electric motor, big machine, something like that you pulls a lot of power and you want to flip that on, you're usually looking for a contactor. If pretty much everything else you're looking for a relay. Okay. Now, the things that you can do with these is just incredible. And the way they work is also very interesting by itself. In fact, I made a whole video explaining exactly how they work and how to use them in the past. And I'll put a link to that video in the description if you want a really detailed look at exactly how the electromechanical switch works and the things that you can do with them. But we're going to cover it much more briefly in this video. So in short, there are basically 4 reasons you might use a relay or a contactor, because for the most part, everything I say about the relay is also true about the contactor. The first most important thing is you don't have to physically move the switch. The switch itself is turned on by electricity. That means we can computerize this process. Now we have a computer that can control a switch, which allows you to do all sorts of complicated things, right? This is how the thermostat in your house works. The computer is checking the sensor. When the sensor says the temperature is at a certain point, it can switch on the relay, or in this case, actually a contactor will switch on the air conditioning unit at your house or the heater. But we're sort of getting ahead of ourselves because you need to know how to program in order to get those more advanced functions, right? I can show you some things that you can do where you only have the relay and you don't even need a computer to control it. A great example of that was the dust collection system. I didn't need a Raspberry Pi or any sort of Arduino or computer controlled anything. There was no programming involved. I only needed a relay with a timer on it. When I switch off the power tool, in other words, I'm done cutting my piece of wood, I want the dust collector to stay on for another 5 seconds or so. That way I can make sure the dust travels all the way through the chutes and down into the dust collecting bin before the system shuts off. The other thing you need to notice about the relay is that one switch controls many switches. All of these little tabs, which I'm going to explain a little bit later in the video, are different switches that are being turned on and off. You can have it start in the off position and turn on, or start in the on position, turn off. But my point is, you can have a really complicated series of events happen by flipping one switch. Many other switches get flipped. And again, they can be flipped on or flipped off depending upon how you wire this. If I walk into my shop and I want something that's been running all night to turn off and a whole bunch of sequence of other things to turn on, you can do that. Another thing that happens with the relay is it allows you to have sensors that can flip your relay on and off. So if you have a temperature sensor, and I'm gonna show you an example of that here in a little bit, a temperature sensor, when it reaches a certain threshold, will open the circuit, you get power to your relay, and you can have that turn things off. So if I have a temperature sensor, say inside of a casing where a motor is running, and I want this motor to turn off before the case gets too hot, temperature sensor flips on the relay turns everything off. Let's say I have a motor moving on a carriage. When it gets to the end of the carriage, it can hit a limit switch. I'll show you examples of that here in a little bit. When the limit switch is hit, the relay can get activated, and you can have all sorts of things happen there. Maybe you want the motor to reverse and start moving the other direction. A relay can allow you to do that. Maybe when it hits the limit switch, you just want it to stop. Maybe you want a whole bunch of other things to start happening when it hits that limit switch. This is the kind of power that you get from a relay. The last benefit I want to mention about the relay is that it's a low-powered circuit controlling a high-powered circuit. And that can save you a lot of money and a lot of space. If you want to control several large motors from one small console, think about the power cable. For example, if my motor needs a cable this size, well, I'd have to run this all the way to the motor, all the way to the power supply, and to wherever the switch is. But if I'm using a relay, the relay needs a very small cable, right? I can have miles and miles of this for the cost of, hundreds of feet of this. You can make those cables shorter by putting the contactor, in this case, very close to the thing you want to control. And then you can have small cables running out, which is where the switch will be. Same principle applies inside of every factory that has a central control panel with motors all over the facility. And that gives you the same superpower inside your home shop. If you have large machines that you want to flip on from one central location, you have the capacity to do that. Now, when you first look at one of these things, it's a little bit intimidating. There's all sorts of terminals for wires there, but as I mentioned earlier, I've explained this in great detail in a previous video, but rather than make you watch that whole video, there's only a couple of minutes of me explaining this specific piece that I really want you to get in this video. So I'm just going to cut that right into this video for you so that you can watch it here. And again, if you want more detail, you can click on the link in the description. Here you can see 4 tabs which are connected to a lever. The lever is actuated by the magnet as well as this spring that's on top. The relay has 2 positions. We have what's called the normal position, which is the one you're looking at now. And then we have the activated position, which is what it looks like when the coil is turned on. When I push this button, the coil should move from its normal state to the activated state. All right, let me stop kidding around with this. Earlier you saw that there's a whole bunch of screws here on the top. All of those screws correspond to some of these little pins that are sticking out. I'm going to pull this ice cube portion out. All of these behave exactly the same, so we're just going to take this first one and then you can extrapolate that to the others. We've got this copper strip which comes up and is soldered to this wire, and if you follow that wire around, you can see that it connects right here. What that should tell you is that this pin can be connected to either this one or this one, depending upon the state of the relay, right? When the relay is on, we're connected to this one, and when the relay is off, we're connected to the other pin. The technical term for these pins is normally closed and normally open. Now, I just threw 2 words at you. Normal refers to when the coil is off. That's the normal state. And the activated or opposite state is when the relay is on. One way you might be able to keep this straight in your mind is if you think of a closed circuit as like a series of walls with a door in it. When the door is open, the circuit is broken and electricity can't flow through the wall. When you close the door, electricity can flow. So in this case, our door is normally closed and somebody has to come along and act on the door. In this case, our coil will act on the door and swing that circuit open. This one is now disconnected and the OLED coil is activated. The same vice versa. This door is normally left open, and when you act on the coil, it is closed and electricity can flow. The most important lesson you can learn from this is that this coil can either disconnect a circuit or connect a circuit. If you're going to use relays, there's a few more things you're going to want to know. Here I've got two identical relays, except the fact that this one has 2 movable strips and this one has 4. The number of strips that can switch contacts is referred to as poles. So this is a 2-pole relay and this is a 4-pole relay. But there's another thing that needs to be added to that, because it starts connected to one contact and then switches to another set of contacts. When you have a pole that switches between contacts, it's called double throw. So this is a double pole, double throw relay. This one is a 4-pole double throw relay. Now, I don't have X-pole single throw relay. Contactors, on the other hand, are usually single throw. So in this case, I've got a 4-pole single throw relay, or technically contactor. So at this point, we've got power to our devices and we've got our relay to switch our things on and off electronically. Let's put a few more tools in our automation toolbox. This is by far one of my favorites, the proximity sensor. A proximity sensor literally detects when it's close to a piece of metal. I connected my multimeter to the output of my proximity sensor, and if I take a piece of metal and bring it close to the sensor, you can see the red light comes on, indicating the proximity sensor has detected something, but also I have a voltage on my multimeter. And that's really important because I can use that voltage to switch on a relay. If I got a 24-volt relay and the current limit on this is 300 amps, so 300 amps, 300 milliamps. So if I have a load under 300 milliamps, which, that's a reasonably sized relay, you can switch things on and off when a proximity event occurs. And this is how you make your projects smarter, right? Because the idea is you don't have to pay attention to the switch or flip anything yourself. The machine is aware of when something is in proximity of this sensor. Detection distance, or the sensing distance, does matter here. When detecting steel, you can see that sensing distance is pretty small. But if I want to detect something like aluminum, it will work, but you have to get much closer. So, that's getting pretty close for comfort there. If I had something moving along a rail, you got to really micro adjust the sensor to make sure it's close enough to go off, but also not get hit. So these are all things that you want to consider when using a proximity sensor. I prefer proximity sensors over something like a limit switch because there's no contact with a proximity sensor. With the limit switch, it has to actually hit it. And that's something you got to be careful with if your machine is moving very fast or you have any concerns about this thing overrunning your limit switch and destroying the switch. But a proximity sensor will never be damaged because you should always set it up in such a way that it doesn't hit the proximity sensor. I've actually used proximity sensors in quite a few projects. The most recent one would be my CNC table saw. I wanted to be able to detect when the table saw blade was all the way up or all the way down so that I could stop the motors from pushing it past its actual physical limits. But I didn't want it to hit a limit switch. I just wanted to detect that piece of metal when it got close and the light comes on, the machine stops moving. It lets my program know, hey, you're at the end of travel. That's, again, just one example, but this could be used in all sorts of applications where you want to detect when something is present or not. I'll put a picture on the screen for you because this label is really tiny. The first character here is brown. The second one is black. And I don't actually know what this character is, but it must be blue because that's the last color that's available. So to use this sensor, we're going to connect the brown to positive. And you can see the sensor is already connected to the positive internally. And the other line coming out is the black line, which means that's your signal line. And then finally, the blue line will be connected to the negative end of your power supply. Now, that will make this an NPN sensor. Sometimes there are PNP. NPN means your signal line is negative. PNP means your signal line is positive. The way I like to remember that is PNP means there are two positives. And since I know one positive and one negative is already connected, the free end must be the signal end. And that is also whatever the extra letter is. A little bit lower down, you can see that the supply voltage is 6 to 36 volts, which means this will work at a voltage as low as 6 or as high as 36 volts. And also we can see that the load is 300 milliamps. So whatever you have connected to this needs to draw less than 300 milliamps for this to work, or you may damage it. Next up, we have limit switches. I use these a lot in every project with any kind of automation. A switch like this could be used to indicate when a machine has reached the end of travel. One of the things that's interesting about this one with the rocker arm is if you listen, I'm gonna hold this near my microphone, I can't talk. Listen for the click. So you see how far it's gone? Now listen for when it releases. That's something you want to pay attention to. There's a lot of difference between where it engages and where it releases. If I'm using this to indicate, let's just say, a normally closed circuit, I've got power flowing, and when it triggers, the circuit is cut off. But you don't get the signal back until it's almost back at neutral. And in some cases you want that. For example, when I was building my CNC machine, I used limit switches like this. When I get the first click, that tells the machine to stop and turn back in the other direction. And when I get the second click, that tells the machine I've arrived at the home position. I like this for several reasons, but the main benefit is you can run into the switch quite rapidly, saving time, and then back off the switch very slowly to get a more precise home position. Limit switches can be wired to be normally open or normally closed, and we talked about that earlier. And the only other thing I want to point out about this is, again, lots of configurations. The push button style, you can see the roller on this one is rotated 90 degrees to the switch, but you can also get them in line with the switch. There are a bunch of different options. So shop around, get you some limit switches, and get that project off the ground. Next up, we have reed switches. These guys are super tiny. I don't use them very often, but I do love the fact that they're really small. In fact, this is really hard to film because they're so small. Basically, as you move a magnet close to the switch, the two tabs will be drawn together, closing the circuit and connecting the two ends of the wire. So I'm going to connect this to my multimeter, and whenever I draw a magnet in close to it, you'll hear the multimeter beep, which means I've got continuity or a connection between the two ends of the wire. And that's basically it. So if you want to detect when a magnet is nearby, you can use a reed switch. These are obviously very small and can't handle a lot of current, but of course you could use this as a signal to turn on your relay or your contactor, and then you can have a much more powerful circuit being controlled by this low power circuit. Beautiful. Okay, there are a bunch of other sensor types that I don't have readily available that I want to mention here. The first one is the temperature sensor. I mentioned this earlier in the video, but I just realized I don't actually have any in the shop, but they work exactly as described. When the temperature reaches a certain threshold, you can open or close a circuit, or you can have a digital one connected to a meter, which will give you temperature feedback in real time, and it'll just display that temperature on a display. Another one that might be really useful is a pressure sensor. When I was designing a baseball cannon with Destin from Smarter Every Day, I'll put a link to that video in the description. Super popular video, by the way. We built this baseball cannon, and one of the things we needed to be able to do was detect the pressure in the chamber to let us know when we were ready to fire this baseball at supersonic speeds. Really incredible. We had a lot of fun.
Here we go. Get ready?
Ready?
3, 2, 1. What on earth?
No.
Where'd it go?
That ball disintegrated.
No, it didn't. It did. Oh, get the.
Hold on, tank is safe.
Tank is safe.
Okay. Shredded, man. Oh, wait, you can see the seams.
Fantastic.
Let me just say, every time I watch this video, I get excited all over again. It just gives me goosebumps to relive that experience. So I'm certainly not going to spoil the video for you here. I'll put a link to it in the description. So anyway, I had this pressure sensor connected to a display so that we could see when we had achieved the pressure that we wanted in the chamber. So lots of options for sensors of all different types. All right, and there's one thing that I want to mention before the end of the video. We'll call this sort of an honorable mention, and that is breakout boards. A breakout board is a device that allows you to take these little microelectronics, like this is called a Teensy. I've got one for a Raspberry Pi here. I've got one for an Arduino. You can see the Arduino Mega is pressed into this board. I love using these because it takes all of these little pins that you would normally have to solder down and converts them into screw terminals. The ones I have here are the DIN rail style because I like using DIN rail, but you don't have to use DIN rail. There are other different types, but the point is it snaps in, it's really solid, and I love using this. But the most important thing is you don't have to solder all your components down permanently. It's much easier to use the screw terminals, and it's really durable. So I love putting these in my electrical cabinets, but this is obviously not a required tool in your toolbox. I just love the convenience of these breakout boards, and just knowing that name, breakout board, will allow you to search for whatever kind of breakout board you're looking for. This video is actually part one in a series that I want to work on for automating your projects. We've covered some of the most basic electrical things that you want to be able to use, and you'll end up using these things very regularly. But now I want to talk about how to make your projects move. So in part two, we're going to talk about the solenoid, which is an actuator for moving your parts. We're going to talk about pneumatic actuators and a couple of other things that I think will be very interesting. I hope you've enjoyed this video, and I'll see you in part two. Thanks for watching.